Thanks, Mar and Arash and Vivian and Per and everyone for hosting us. Excited to be here. My name's Harrison. I'm the co-founder and CEO of LangChain, and I'm excited today to be chatting with James. There's a microphone, I think, down there. I met James. There's two microphones. Yeah, we're double mic'd. I met James, I think 2 years ago, roughly, when we were both kind of like exploring the Gen AI space, and we've stayed in touch, and it has been awesome to see what you've been doing with Character. Maybe to start, do you want to give people a little bit of your background? Because I think that speaks to some of what we'll be talking about today.
Sure thing. And thank you to Per and to LangChain for hosting this event and having us to speak about the story of Character. I guess like the most relevant history for me is I joined Google Brain in 2019, where I eventually met Noam and Daniel and a bunch of the founding team of Character over the years, and spent about 4 years there working on dev tools. I worked on systems with DeepMind that gated access to the TPU and GPU fleet, and helped researchers define experiments and training loops, etc. And 2 years ago, I made the leap of faith back into startup land, where I was prior to Google, to join Noam, Daniel, and the rest of the founding team to help scale the product. And excited to talk about that today.
Yeah, let's talk about that. Most people are probably familiar with Character in some form. But do you maybe want to give an overview of the product that you all are building and maybe how it's kind of like evolved over the past 2-3 years?
Yeah, if I could, I'll go back to 2017, and maybe even earlier. So Noam and Daniel. Noam was at Google actually from 2000. Has hundreds of patents to his name. Has pushed the industry, like the machine learning AI industry, in more ways than just about anyone else in the world, I think. 2017, he was one of the primary authors on the attention paper, and Daniel DeFreitas had this lifelong dream of building an open domain dialogue agent that was unconstrained from the very rigid NLP, rule-based systems that were the standard at the time, and those two got connected inside Google. And why I connected with Daniel is because he was begging people for TPU credits to train larger and larger models back in 2019. And eventually, that pairing plus a whole bunch of 20% work formed the product that was sort of behind the paper Lambda, which then actually was preceded by Mina internally at Google, then became Lambda, and then in 2021 they left Google to try and give this technology to the consumers, and see what they wanted and see what they did with it. The most ironic thing about Character's founding story is that it was a case of just build it and they will come, which sort of broke all of like the rule numero unos of the 20-teens. So exceptional story, exceptional pairing. And we launched about a month before ChatGPT came out in October of 2022. And having rebuilt the sort of research from the ground up. And then in January, we went from, I think, like 300 generations per second to this summer we were over 30,000 messages per second. So we went through like 2 orders of magnitude in about 18 months.
And that's the third kind of like highest QPS?
Yeah, I think by enough sleuthing, it's about the third most used Gen AI application, probably behind Meta and OpenAI. I might give a brief primer about what Character maybe is as a platform, and how we're sort of different to the ChatGPTs of the world and even the Meta AIs of the world. It's all premised on the notion of UGC prompts, basically, that are characters. And so when as a new user to Character, you're sort of met with 200 million, community-created characters that are effectively just prompts, behind the scenes, and you can go and discover, well-known characters from TV shows. You can go and discover, generic characters like a therapist character or a best friend character or a language learning character, and obviously on the other side of that sort of marketplace, you can create your own character, and it's super duper simple. It's all it is natural language prompting, it's actually really difficult to define like what is the whale use case, because there's a super long tail of users, and even within a single user, they might have a plethora of use cases that they come to the site for, given that this is so like open domain, and you can talk about anything.
That's part of the power of Gen AI, I think. Cool. Okay, so you guys launch right around or right before ChatGPT. I think a lot of people in this room are probably building with apps, and or building apps with Gen AI. They've probably launched apps. Probably no one in this room has reached the scale of Character.AI. What was that kind of like journey like? And as people are building, as hopefully they're able to kind of like, build apps like this, what should they expect kind of like along the way?
Yeah. So I think for a lot of us, last year was really like the hyper growth year, and it was probably, like speaking for other people, but definitely myself, the most rewarding year of our lives in our careers, because as this whole industry is taking off, we also have a exponential user growth.
And what kicked that off? Was it just kind of like more eyeballs on the space, more tailwinds, or?
Yeah, I mean, I think that we rode the coattails of ChatGPT, and like ChatGPT sort of brought to the eyes of the consumer in more of the mainstream what this technology was, and then as regular consumers online sort of were exposed to the technology, then some fraction of them gravitated towards this different experience. People talk about Character being more fun, more engaging than like the competitor app.
Did you think that would be the case, or did you think it was like when they started growing, were you like, oh no, this is bad for us, or did you kind of like realize that it was going to be a whole wave?
Super good question. I think it was initially competitive, and I don't think it's one thing to say, but it's another thing to like fully embody in your brain that the rising tide lifts all boats, and like the TAM, like the market, is expanding as we're building, and so it wasn't really a zero-sum game at all, but it's really easy as the sort of default mental model that I think we had initially, but yeah, the scaling story, it was I would say a pretty standard monolith to services, and dropping the micro part via database sharding story, with I think 3 core differences, given that it was this LLM, like this new technology.
And differences from traditional kind of like app scaling.
Yeah, exactly. Different to like a traditional consumer application of the 20 teens.
What are the differences?
I think that number one, the volume of data per second that you're having to like wrangle is order of magnitude higher than prior generation social companies. And the reason is because you've got to build this prompt every single message. Like the most heavily used sort of user path is generating a response, generating a message. And for every time you generate a message, you've got to pull the entire chat history, likely from cache, a lot of it. But you've still got to like, you're piping that many bytes through networking layers that many times a second. And so I think we're like our network does 7 or 8 gigabytes per second, just on this hot path for generation. So that's like insane volume of data, I think is one. The second is cost. Like to serve 30,000 messages per second costs a ton of money in GPU spend. And so there were, like last year, like this is sort of correlated with latency too. Like you can pay more money in over provisioning servers, like over provisioning GPUs, to lower the latency. And we all know that like consumer number one is like better latency. Like the easiest thing to do to improve a consumer application is like improve latency, but that costs a huge amount of money. And so what else can you do? You can like prune the number of parameters that you're serving at runtime.
Parameters in the models themselves.
Parameters in the models, yeah. And so we...
And maybe just to make this really clear, because I don't think we've touched on it, but unlike probably most apps building in the space, you guys were building your own models from day zero, like foundation models, not fine-tuning.
Yeah, that's exactly right. And that's part of, like Noam and Daniel and the rest of the founding team's sort of gift to the company is that we had, until recently, until Google bought essentially the research from the company, we had our own pre-training through post-training stacks, which meant that we could make architectural decisions like multi-query attention way like upstream in the pre-training process, and serve that, knowing that that actually didn't hurt engagement. It didn't hurt our core metric as much as a competitor that's serving a more intelligent-based, product experience would see. And so we were able to not just like take a given architecture and like post-train some like style into the model, but like actually make pretty significant architectural decisions way upstream in the pre-training process.
And that also let you control speed and latency more?
Precisely, yeah. I think like just like MQA gave us...
What's MQA?
MQA, multi-query attention. It gave us 5x reduction in our like GPU cache. Why is GPU cache important? Because for every message that we generate, we cache at each layer in the model the result of the computation. And the result of the computation is dependent on the prompt up until that point. When you think about Character.AI's use case, the n+1th generation, meaning like when you're chatting, like the n+1th message that you send, the prompt looks exactly the same, modulo the new user message. And so by utilizing this GPU cache, which we now have 5x more of effectively per GPU, we can actually pick up all the computation by like the 5%, that's how it, 5% at the end, which is the user's message that we haven't computed over yet. So if we didn't have any GPU caching at all, and we have like a pretty comprehensive scaling inference part 1, part 2 on our research blog if you're curious, we would be bankrupt like tomorrow. So we have like a 95% cache hit ratio, which allows us to serve this GPS at a decent cost. So I think like cost is like the second biggest difference, is like to serve the core user experience. There's a whole bunch of engineering challenges that we had to face head on, including architecture changes, including caching, including like sizes of the model, in order to serve at somewhere that's cost effective for us. Third thing is the total response time is, I think P50 is like 12.5 seconds today, meaning like that's the time it takes to generate an entire message. And back last year, I think it was probably like 25 seconds. And the first chunk, like the time it took from a user to send a message and get the first like, first like 8 words and a response, that's like 5 seconds. But 12 to 25 seconds, call it, you're having to like maintain that open connection between your service and the clients. And so like you multiply that duration, 12 seconds, by that QPS, and you get to like 400,000 open connections to all of your, like in total across all your machines. And so like that also means like, A, you got to scale the number of pods. B, you've got to make sure that each connection is somewhat lightweight, so that you can, keep them open and you're not like ooming the machines. And there's a whole bunch of pressure you have on like your like services and your system components, like your Redis cache layer, for example. And your networking layer. So I think like this is another like very unique thing that was different from like consumer applications of the 2010s.
One of the things that we hear a bunch from people as they're building their apps is kind of like a trade-off between performance, latency, and cost. And you kind of mentioned a few of those as you were talking about kind of like scaling out the app. How did you guys think about that internally? Did you prioritize one more than the other? How did you measure it? How did you kind of like decide the trade-offs to make?
Performance meaning quality?
Yeah.
Yeah. So I nothing was particularly scientific. As we were sort of like building the plane as it was taking off. Every time we made like improvement to like a core latency metric from the model, we could trade that off with cost of serving. We could either hold like the QPS per GPU effectively constant and drop overall latency, or we could serve our entire sort of like demand on fewer machines. It was probably mostly mediated by the research demands, like if we're kicking off like a massive hero run, for example, over 3 months, we need some fixed capacity to train that model, and so we might increase the consumer, like first-party platform, Character.AI latency. We might bump that up in order to take some machines and assign them to research. That was probably the biggest trade-off that was made.
Makes sense. You're scaling like crazy over the past year. Were there any kind of like horror stories, war stories, funny stories that popped up as you were trying to continue to scale the platform? There
was one particularly funny story. I think that like relates to how different, like to a challenge that is unique to scaling these types of products as well. And it was to do with this GPU, like local attention cache that I mentioned. For a couple of months, we had rewritten our serving code paths. And so these new serving code paths indexed the results of these computation into the cache in a slightly different way. Whenever we post-trained a new model and did an A/B test on our site, we found that like not only were the results like neutral to negative, but like they were very negative. We were like, what? Like the token budget was like 5x the previous model. Like the data quality, like the data mixture was like so much better. Like the architecture was so much better. Like how the hell is this happening? And like it responded with coherent like responses. And so like the tests that we ran for like to test the contract of like message in, message out, it was like they were all passing. It was fine. Just so happened that like when we rewrote those code paths to index the results of computation to the cache, we missed indexing the results of the computation for user messages. And so, like, on the successive generations, when we picked up that 95% cache and computed the last 5%, what the model was seeing effectively was character, like in the prompt, effectively, was character definition, character message, character message, character message, it's like it was talking to itself and missing all of the user messages. And like, obviously over time, like the users are like, what the hell is this? Like, this sucks. Like, and time spent like tanked 12%. And we're like, what? And so we fixed that bug, and like an artifact, like a model that we had lying around, we like fixed it, ran an A/B test, and it won by like 24%. And we're like, oh shit! Like that was like 3 months of of like banging our heads against the table.
How'd you find the bug?
Our mutual friend Sam Schleifer was bugged so much by people saying like, this doesn't feel right to me. Like vibe check, I know tests are passing, but like something's off with the quality of this model. And he was bugged like so many times. It was like, okay, like fine, I'll look into it. And like eventually, it was like probably like a 3-line change to fix the bug. So,
nice.
I would say the other like maybe like different for this audience. The other like the Achilles heel of scaling this product was the database layer, 100%. And like the funniest and most catastrophic like war story we have in the database is like, I think in June of last year, a bunch of us woke up at 5 a.m. PST, and we had a teammate in New York at 8 a.m. to say like, hey, like the site's going down like yet again. Okay, like put maintenance mode on, we'll look at it. And we all got into the office. We realized that like there seemed a difference. Like there was database issues, latency was spiking. There were a whole bunch of open connections to the database, and we were like, it seems different to what we've seen before. There's no easy fix. And by 11 a.m., we found like a reasonable hypothesis from Google, who was hosting our Postgres instance at the time, and it just so happened that like there was a bug in Postgres, like core Postgres, that was triggered by a function of our sort of query volume and characteristics, and by their wrapping of Postgres, which meant that when Postgres, like when you do any transaction, when you write, update, or delete, a transaction ID is issued for bookkeeping purposes, XID. And those XIDs are garbage collected like periodically by this vacuum procedure. And it just so happened that like Postgres thought it released an XID, but it hadn't. And the way we found out was we had this post feature where a user could post like a snippet of their chat. And every time a user would load that page, we would update some metadata about how often that page was viewed. So we'd issue this DML transaction, like update the record. So we needed an XID. But we couldn't update the record because the prior XID hadn't been released. And the post that was responsible for this corruption on like disk on the page was this grilled cheeses post. And no reason why it would be the grilled cheeses post, but it was this like character that was a mix between a grilled cheese and Jesus. And it was a really funny, I mean, like no disrespect to people that are religious, but it was really, really funny, like the snippet. And like by total coincidence, it just happened to be this post. And so eventually, like later then at 1 p.m., we realized we have 16 hours left of issuing XIDs until the entire XID space had been consumed, and we would need to take the database offline for 7 days to do a full vacuum procedure to like go and like manually release all the XIDs. So it was like, do we roll back to yesterday's backup and say that you've lost, like to the users, that you've lost a day's worth of data? Do we try and fix forward and like in 16 hours hope we find a solution. Like what are we gonna do? Eventually, at like 1 a.m., we successfully ran a like partial vacuum on a backup that succeeded. And then we decided to run that same vacuum on our online database and took the site down for like 30, 40 minutes. So yeah, it's funny because like on the one hand, like how did we trigger this like random bug in like low-level Postgres bookkeeping? But on the other hand, like it had to be this grilled Jesus post that like is super famous.
Jesus almost took you guys down.
Yeah, totally.
As one of the first companies kind of like in the space really building that scale, what internal tooling did you guys build to help you iterate, develop faster?
Yeah. So one, this is gonna sound like super trivial, and like it kind of is, but at this scale, there are so many like components involved in the hop path that when we were like last year building out, like going from monolith to services via the sharding strategy, the way we were constructing the prompt to feed into the LLM was effectively concatenating to a string and like slicing into a string over 3 different components. So like we would build part of the prompt and like via gRPC protobuf we'd send to a separate component, and we'd get some more data from a different database and like append concatenate to a string, this meant that like this very janky way of like concatenating, slicing into the prompt meant that it was almost impossible to change the prompt in any significant way without introducing bugs somewhere. And the most classic examples when we launched group chat. When we launched group chat, rather than the prompts for the LLM being character definition effectively and then the chat history, it was now like a couple character definitions, because you could have multiple characters in the chat, and then the history. But just doing that, just having a couple character definitions was complex because we had so many layers. And I think we spent like 2 weeks just making that change with like good engineers, and introduced like 3 or 4 bugs in the process. And so we built this tool to sort of solve the problem of iterating on the prompting layer, and most importantly, running experiments. Like when we make a change to like even a trivial change, like a formatting change, like using colon space. We want, at this scale, like we want to know what the performance impact was, the engagement impact. Like did it regress some quality somewhere? What happened to time spent? What happened to number of messages sent to the control versus treatment? And so we built this tool called Prompt Poet, which allowed us to basically templatize our prompts in this YAML and Ginger layer. And we use Ginger to sort of interpolate runtime variables and also execute control flow. So you can condition, like in the prompt template, you can condition on the value of a variable, or you can loop through some iteratable that you pass into the Ginger render function. And then the YAML layer was useful because we don't have an infinite context window. And when we sort of have context overflow, we want to truncate in a smart way such that we don't blow this 95% cache every successive message. And so we had to do this smart truncation implementation, which was also very useful to have like this structured YAML, and we can assign a truncation priority to each part of the YAML so that we can take out less important things from the prompt first, and not take out like something that's critical, like the character definition, for example. And by character definition, I mean the UGC, like user generated content prompt that is the character.
And you guys open source this, right?
We open sourced it. Yeah, after actually, like the original name of this tool was and it still is Hermes, like the
Greek god.
The Greek god like communicates with the gods.
Yeah.
Yeah. It was like, and so like like we built this tool to communicate with the gods, meaning the LLMs. I bet you Yuval Harari wouldn't be happy with that. And we baked in a whole bunch of like character implementation detail into Hermes, and then stripped all of that out to open source this now very lightweight package called Prompt Power, and it's we're hoping to put more investment behind it, but it's got some decent traction.
People should check it out. We're gonna go to questions after one more question. So think of stuff you want to ask James.
Don't be shy.
What's next for Character?
Yeah. So I think part of the answer is probably mentioning that we went through, I'm not sure if everyone saw, but we went through this sort of deal with Character, with Google, where Google sort of licensed our core research and hired like 32 researchers from the pre-training, like the entire pre-training team. Which for us meant like internally, like we went from Character 1.0 to Character 2.0. Character 2.0 is much less focused on pre-training our own models. We still have a very strong post-training team that sort of post-trains our models on preference data that we collect from the product. But the shift was going from like this aspirational AGI research lab to like 100% focused on the product and the users. And so in that vein, the sort of 60% bet right now for like in terms of resources of the company are on new formats and big bets. So we want to explore, new user experiences that sort of break out of the chat messaging sort of response paradigm into more multimodal experiences. How can we generate artifacts on existing chat transcripts and maybe like build a feed or build something that is like new and exciting and only possible with this technology? The sort of like 20 to 30% focus is on the current core product, like making sure we finish the loops and tighten up the existing user experiences, and the 10% bet is like to the one of the like points I brought up earlier. Like it's very costly to serve at this scale, and so like we're gonna make some money, and I think there are very easy ways of doing that.